Yeah, I'm Tadeu, and regardless of the title of the talk, I'm here to talk a little bit about how React Native works internally. A little bit, what? A little bit about me. I joined Facebook a little bit over 1 year ago. I joined as a front-end engineer in the iOS team, which is a little bit funny. I joined React Native a little bit before it was open source, and I had the pleasure with of working with this team to the open source project. And then I started getting more interested about performance and tooling for React Native. And we started a new team called React Native Performance. That's actually what I do now for the past 6 months or so. And before I start talking about React Native, just a short story. So we have this tradition in London, in the London office, of going out for burgers. Now you can see the picture. Uh, we go almost every Wednesday, and this has been going on since before I joined. And it's pretty cool. Everyone gets together, we talk, we have a beer, and in one of these burger lunch, we somehow got talking about the classic interview question: what happens when you type a URL in the browser and press enter? And there's a bunch of resources in the internet explaining that and how it works and in depth. And but what we're talking about is how this can get tricky if you decide to go DFS. So if the answer was a graph and you go in depth, you can go so deep that you never get to the next level. So you can spend so much time in one specific part of the problem that you cannot cover the whole surface. So we kind of got to an agreement that the best way to approach these kind of questions is to go BFS, which breadth first search. So you cover all the surface, but very superficially. Then you come back to the next level, and we kind of agree that that's better because you can cover more, and you can always come back and explain more about something. And what does it have to do with React Native? Absolutely nothing. But then I got home, I was going to sleep, and I just realized that could apply for React Native. So what happens when you run a React Native app? So it's kind of the same problem. You could spend the whole day just talking about iOS, how iOS works, but I tried to create a BFS graph, and that's what I came up with. The image is not great, but I'm going to zoom in, so don't worry. But before we dive into this graph, just a few concepts to make sure that everyone can follow through with. If we're not very familiar with React Native, it should still be okay. So a few things, like when React Native came out, a lot of people, the first question was like, does React Native use a Webview? So now more people know React Native. It's getting less visual, but just be sure, there's no Webview. There's no HTML. There's no CSS. There's only JavaScript running in JavaScript core. That's the JavaScript engine that ships with WebKit and is available by default on iOS. So it's only JavaScript. So JSX slightly resembles HTML. It's not HTML. We compile JavaScript. I guess you guys all know. The inline styles resemble CSS, but they are not cascading, and they don't follow the spec. So it's not really CSS. It's intentional. It's to make it easier for web developers to use it, but you should keep in mind that it's not exactly the same thing. I just want to cover it. So, and the other thing that I want to just briefly talk about is that there's this big thing about React Native, that's the bridge. So the bridge is this key piece of the architecture that controls the threads. So we have three main threads in the left. That's like the main thread, that's actually called the main thread. That's always the system thread. It's a thread that your app runs by default if you write a native app. And it's where you're going to deal with all the native UI and these kind of things. After that, we have the JavaScript thread. That's a thread that we create to run all your JavaScript, and it will belong to the VM. So it's only dedicated to the VM, and we try to run our JavaScript separately to avoid contention in the main thread, so your app can continue running smoothly, even when you have a lot of JavaScript execution. We also have the shadow queue. That's where the layout happens. We call it the shadow queue because it only knows about the shadow nodes that are these data structure that only has information about layout. So things like the flexbox properties, width, height, and this kind of information. We also have like the native modules, things like networking and local storage or images. They are completely pluggable, and each one of them have their own threads, at least in iOS. That's by default. Even if you create your own module, like there's a custom module there, it by default, if you don't specify in which thread should run your module should run, by default it will get a new thread. So there's the ones that are marked that are actually queues. So queues are built into iOS and their thread pools. They can be smarter and start and they can create and destroy threads on demand. So that's not too important, just so to know that that's how the execution is separated. And now we can go back to the graph. So we start at the very top with when you run a React Native app, but which app, right? So I just created like the simplest possible example. So even if you have never seen React Native, but if you've done React, that should be okay. The text element is just like a span in React.js. And we have this app registry that allows you to register a component that's going to be an app that can be triggered from the native side. So this is what the app looks like. So yeah, just it. It's not responsive. It's not responsive. It doesn't do anything. It's just nothing fancy. But let's see what React Native is actually doing behind the scenes. So first, it will have to load your script. So your script is going to be bundled by the packager. React Native ships with its own packager, but similar to Webpack, if you've used it, or Browserify. So it will just get all the dependencies and put into one single script. And React Native will only deal with this one file. So as soon as you start loading your app, React Native will kick this process in a background thread, so we don't get hung up loading your file. And it will move on to loading the native modules. So the native modules, as I mentioned, could be image, networking, local storage, your own custom native code. And this process kind of separate, it's split between the bridge and the module itself. So when you create a module, it really doesn't need any boilerplate. It's just that code. The only thing that you need is that macro. When you export a module, you add that macro, it will actually generate these two methods. The first one is not really important in this context, but it's just an alias for the module. If it's empty, like in this case, that's the most common case, it will just use the name of the class. That's my native module in the example. And the load method is an special method in Objective-C that will be called as soon as your class loaded into memory. So what that means is that as soon as your module is loaded into memory, it will call the bridge to register this module. So the only thing that the bridge does at this point is that it records that it knows that your module exists. When you start actually loading your app, it already knows about all the modules, and it can go through them and create new instances that your app can use. In parallel, it will also start creating a new instance of the JavaScript VM. It will start a thread, create a new instance of the VM, and provide all the native hooks that React Native has. So things like logging, high precision timers, shortcuts for optimizations that don't need to go through the bridge. All the synchronous methods that React Native exports to JS are done at this part. Once both of them are done, we can combine them and load the JSON configuration. The JSON configurations just looks like that. It's basically an array of modules, and the module itself is another array that just contains the module name, the content that the module exported. So you can export content from native views, for instance, like the size of the date picker. It's a real use case for that. And the methods that your module has. So that information is important because the JavaScript will use it to create the object at runtime. So when you require a native module and you call a method on it, that object has never been written. That's just JavaScript goes through this configuration and creates the object at runtime with placeholder methods that will call back to native. Once you finish configuring your environment and your JavaScript finishes loading, we can actually start executing your JavaScript. So here there's a few things that are interesting to know about the VM. I can't, of course, cover everything, but just a basic look at it. So when you pass some script into the JavaScript VM, the first thing it does is copy the bundle. So if you modify the string, it still has the original copy. After that, it will start parsing. Once it parses the code, it will generate some the abstract syntax tree, or AST for short. Then from that, it can generate the bytecode, and then it can finally execute the bytecode. But the VM is smarter than that. So the reason there's a dashed line between the AST and the parse, between the parse and AST, is that the VM doesn't want to parse everything. Parsing is expensive, and generating the bytecode is even more expensive. So as soon as it finds some code that won't be executed right away, so like a function, it will just switch to a syntax checking mode. So it will stop generating code, and it will just check if your JavaScript is okay. When you try to execute that function later, it will parse it again in the code generation mode, and then it will generate the AST, the bytecode, and finally execute it. So yeah, that's just a very high-level view of how it works. If it was an Android, it could have a JIT. JSC, for instance, has like 3 levels of JIT. So, but none of these works on iOS, sadly. So here I added this abstract JavaScript execution. So this doesn't really match a piece of code. So this is only to simplify the graph, because the JavaScript execution has 3 or 4 different entry points. So you can call a callback, you can call a method, you can execute the application script, or you can load some configuration. And that would just result in 4 nodes, all with the same descendants, and it would be a mess of a graph. So here's like anything that's going to the VM will go through this node. So once we execute the JavaScript for the application that I showed, it will create the text component, and it will have a shadow view. The shadow view will have the layout information. Once we finish creating all the shadow views, we can compute the layout in a background thread. So these will generate an absolute position and size for the text view. In parallel, we'll start creating the native views that will be used to render the actual app to screen. Once we have both of them, we can combine into the final layout of the application. And we got to the end of the graph. But if you remember from before, there was more stuff. But with this app, this is as far as we can go. If we add just like a couple more lines of code there, we add a touchable that on press will just show an alert. So again, nothing fancy. You just open the app, you tap the button, you see hello world. So it's fine. But we just added user interaction. So now the user is interacting with the device. The device recognizes the touch. That goes to UIKit. That's Apple's UI framework. React Native has its own touch handler that will send that to the native module that dispatches all the events to React. So React.js will get those events and will call the method, the handler, the onPress, that we call alert. But if we look into the definition of alert, it's actually calling alert iOS. And that's a native API. So if we go back to the graph, now we have another entry. So now we're calling back to native again. So native goes to the bridge. The bridge takes an array of calls, and it knows which call goes to which method, to which module, and which thread does it have to run. So it tries to be smart and not do a lot of thread jumps, so it will aggregate calls and do some pseudo clever thing, and eventually it will get back to the native module. So the native module here will be the alert manager that will show the alert, and it can call back to JavaScript or not. In this case, it doesn't. It just shows that alert, you click OK, and you're done. But if we go back to our example, we can add handlers to the alert. And if you click OK, it will just alert OK. And if you click cancel, it will just click cancel. It will just alert cancel, sorry. So, yeah, same video, nothing fancy. You show the alert, you tap OK, you see OK, that's it. You tap again, you press cancel, you see cancel. But if we go back to the graph, now we have two different entry points in the graph. The first one is the blue one. So that's when we tapped the button. That was handled by React Native because the button was a React Native component. So it went through the UI kit and called the native module, and the native module showed the alert. The second time, when we click the alert, there's no React Native anymore. The native module is handling the alert, and it registers a callback, and it knows which button you clicked, and based on that, it knows which method should it call in JavaScript. So it goes straight from the native module to the JavaScript execution. And now we traverse the whole graph. Now you know all about React Native. That's all you have to know. That's not true, but what I hope with that is like React Native is a new technology, and a lot of people have questions about performance and how it works. And the idea is just to try to make it a little bit more clear what's going on, so people can either understand a little bit more or have questions about it, and hopefully start contributing to the core. And finally, thank you. Not just for listening. A big part of React Native and React is the community. Like, you ask anyone why they like React Native, and they say the community is amazing. You ask anywhere, people are super helpful, and without that, people would just choose other frameworks. And thank you. You guys really make React work as well. So yeah, that's it, and it was really fast.
We have plenty of time for questions, so if there's any questions for Tadeu, please fire away.
Thank you very much for your work, and thank you for thanking us. So within the React Native world, it seems like iOS is always the favorite child. It's easier. There's seems to be more of the native components supported. I just wondered why that was. Is it just because you guys like working on iOS more, or is this a deliberate decision?
React Native started like long before it was open source, but it was like a slower development. It was an experiment. It started in a hackathon. It slowly developed. It started on iOS because they already had WebKit there, and they knew how to do that on iOS, and they worked on that for quite a while until they actually believed that it was worth getting more engineers. And the first team to have native developers was Android. But the thing is that the iOS version was already in development for maybe 1.5 years. Peter and Felix might know it. Roughly 1.5 year. So, but the Android team started before than iOS, the native one. We are catching up. There's more people working on Android today than iOS. It's just it started earlier, but one of the top priorities for these years, like getting them in pair. So we don't prefer iOS. We want them to be the same experience developing for iOS or Android. The idea is not to make it absolutely cross-platform so that something that you write to one work in the other, but the experience should be the same. Yeah, that answers the question.
You noticed you mentioned that JavaScript core on iOS doesn't have JIT, but Android does. Does it mean that React Native works faster on Android than the iOS?
Okay, so JSC doesn't have a JIT on iOS and does have an Android. So it's not that JSC doesn't have a JIT on iOS. So iOS doesn't allow you to allocate executable memory. So it means that you cannot generate code on the fly. So the JIT is there, but it doesn't have permission to be executed. Only Safari can use it. Or if you use WK Webview as well, but you cannot just use JavaScript core and have the JIT. But that's a OS permission thing. It's not due to JSC. It means that Android can execute faster JavaScript than iOS, maybe. But that's a very complicated question because JIT is a very complicated thing. Like there's throughput, so we have like three tiers of JIT. So there's the baseline JIT, then you have the TFG, then you have the FTL that was recently replaced with P3. And on Android, you would think that the more tiers you have, the faster it is. But in Android, for us, it turns out that we only have the first level enabled. All of them could work, but it doesn't give us any perf benefit, and it increases the binary size.
But did you measure performance on Android versus iOS?
It's complicated because you can't run the same app. I didn't run a JavaScript benchmark in JavaScript only in an iOS and Android. I haven't.
Okay, thank you.
Hi, thank you for the great overview. I'm wondering, we have an existing iOS app, and I'm trying to integrate React Native there, and we do a lot of testing on iOS, and I'm wondering, testing with React Native. I haven't seen many examples. With the F8 app, I hoped that would be a great set of examples, but unfortunately didn't have it. And I'm wondering, internally, what do you do? Do you do snapshot testing? Do you otherwise test, and or maybe even outside of the simulator?
That's a good question. Yeah, we have some tests in open source. We did have more snapshot tests at first. Now we have more end-to-end tests. So for the framework, we do have some unit tests and some kind of integration tests. But for the products, we just end up using more. Some products have tests on their components, like unit testing for components and integration tests for components. But what we rely more on is actually end-to-end tests in the end. So just end-to-end flows of interacting with the app. That's what's worked best for us, I think.
Yeah, okay, thanks. Makes a lot of sense.
Hi, thanks for the nice overview, but also I was wondering, because last week we had heard about Windows support. Microsoft is behind it and doing a lot of work, what you're now explaining, what you had to do for iOS and Android. I was expecting that also Apple would help OS X wise. Are there what are the big difficulties to put support for OS X with React Native or Linux? Could you emphasize, or could you explain a little bit about that?
Well, from the Facebook side, I think that the biggest thing is that we don't really have a use case for it, and I mean the engineering team is not that big. Like we already have like really a lot of work with iOS and Android, so adding a new platform now for us just it's not viable. Like it doesn't give us enough value. The thing with Microsoft is that it was they wanted to support it, and they basically just did that on their own. It was amazing. If anyone wants to support any other platform, it's fine. Like we'll be more than happy to help to provide support. But right now we just don't have enough engineers to add a new platform, and yeah, so we don't have any short plans of doing that.
Thanks.
Just a quick one. I just wanted you to maybe say, for everyone who's here who might be interested in learning React Native, what would be the easiest way for people to start contributing, even if they don't know that much about native development?
I think that's more like a general thing. Like I think the easiest way of contributing to any projects using it. It's very hard to contribute something that you don't use. And I speak for experience. Like before, I was always super like hyped about like I want to contribute to open source, but I didn't use open source. I just wanted to write code, and I didn't know what to do. Like I was really willing to code something, but I didn't know what to do. And as soon as I started using open source stuff as part of my workday, then you find bugs, you report in. If you can help, you contribute. So I think it's like if you are interested in React Native, if you want to contribute, start playing around. It's not perfect. You will probably find something that you think could be better, even in the docs. Like a lot of people help with the docs, and it's really helpful. Since we open source, the docs have come a long way, and still like there's plenty of stuff to improve. So just try it out. If you see anything that you think it's not working as it should or it could be better, just open a pull request or open an issue if you're not sure what to do yet. Ping us, and we'll be more than happy to help you contribute.